Okay, example 10. A random sample of 70 batteries is drawn and X is measured like that. Calculate the mean and variance of this sample of data. Mean is just summation X over N. This one, right? Not difficult, correct? You get 10317 over 70. You will get 147.39, which is equal to 147.37. I want to highlight this. The question asks for the variance of this sample of data. That means they are not asking for unbiased estimate. That means they are asking you out of this 70, correct? What is its variance? That is the sample variance. So it cannot be n minus 1. If it's sample variance, it must be 1 over n. Let's distinguish that. So we use our O-level formula, 1 over n. Correct? You learned before. Correct? Now then you use that. I want to emphasize this sample variance, this formula is not in MF15. MF15 only give you the S squared, the unbiased estimate formula. Follow? Can? All you need to do is to substitute your n equals to 70, in. All those are given. Correct? All those are given. Summarized data given. Okay, and the values. You can easily call. Part 2. Part 2. Using the above data, find unbiased estimate of the population mean and its variance. So now we want to estimate the population. Let's be very clear. What happens is this is the population. What you did was only collected a sample of n equals to 70. This is just a small subset of the population. What you have calculated is just now the mean of this 70 was mean equals to 147. Variance, sample variance was the 281. But the question is asking, can you use this data that you collected to estimate the population mean and variance? Quick answer, for mu, no problem. You can safely use that. It is an estimate, an unbiased estimate must be the sample mean. Same, good enough. Correct? What about an unbiased estimate of the variance? As long as you see unbiased, as you want to know the population variance, you have to use S squared, which is given in MF15. This is given in MF15. Yeah, this is given in MF. You want to make use of 200. You want to make use of this group of data to estimate the sigma square. Then you just sub in the values. You will get 285. You realize that it's 285, not 281. 281 obtained earlier was the sample variance. 285 is the unbiased estimate of the population variance. See what I'm trying to say? If you are lazy, you can make use of this. I do not expect all of us to remember this, to be very honest. Actually, I don't expect, but it can be easily derived. That means you have actually found sample variance earlier, 281. Correct? All you need to do is to take 70 over 69 times 281. Follow? I don't expect all of us to remember, but if you want to use it, you can also use it. Correct? Yep. Example 11. Am I going too fast? No, okay, Oh, okay, yeah. Thought the example, example quite fast, quite easy. Wrong. Okay, I want to emphasize 11, example 11, because sometimes the question will give you this kind of data. Let's see. I will go a bit slower for this one. I want to start this a little bit more. Okay? A little bit. Exam. Sometimes questions will be phrased like that. A sample of 10, instead of telling you summation x, they tell you summation x minus 20. That means for every x value, they minus 20, every x value minus 20, and then they sum them together. Okay? Can I have attention? Why do they do that? We call it coding. Actually, don't even know the name lah. Okay, coding. Why? Because if you take every single value minus 20, you actually work with a smaller value in the summation. It's easier to work with that. You follow what I'm saying? Okay? Especially when you square it, if you don't take minus 20 and then you square, you will work with very, very big numbers, very troublesome. So that's why they sometimes we do coding. And the question sometimes give us that, so we have to learn how to deal with that. The trick here lies here. Can you highlight this one? You need to let y be equals to x minus 20. This one very important. This idea, this one is very important. You let y be equals to x minus 20, then the summarized data given, summation y is now 40, summation y squared is now 624. Correct? Because y is now x minus 20 ma. So they give us summation y, they give us summation y squared. Then can you find what is y bar? Actually, y bar can be easily found. Y bar is now summation y over 10, which is equals to 40 over 10, which is 4. Now, if they give me summation y squared, I can also find the unbiased estimate of y. Unbiased estimate of the variance of y. Follow so far? One more time. If I know what is the summation y, I know summation y squared, I can find the unbiased estimate of the variance of y. So, I use formula, I can get this. But actually, we have not fully answered the question even if we do that. Correct? Because what you have obtained now is 4 and 6, 4, 6. Yes? I write down in words. This 4, which is the mean of y, is the unbiased estimate of the mean of y. This is the unbiased estimate of variance of y. But the question asks us, what is the unbiased estimate of the population mean and variance of what? Of x. Correct? We want x, we don't want y. How do we then do it? This is then important. This idea is important. Wow, so fast. Wait, let me see. Actually, very fast. Okay, finish. If y is ax plus b, y bar must be ax bar plus b. This one will be quite clear. And this relationship also applies. Actually, what you can say is, you recall expected value of x. Sorry. Correct? And variance of ax plus by. Okay, you know. Follow what I'm saying? So, it is not difficult to identify that now, if y is x minus 20, x is y plus 20, x bar now is actually y bar plus 20. So all you need to do is 4 plus 20, you get 24. Follow. Now, so therefore this is 24. Okay, last two boxes. Sorry. Okay? Now, if x is y plus 20, you realize that. Have attention, please. We are here. X is y plus 20. You plus 20 to all the values. You just translate all the values by 20. The variance will not change. So the unbiased estimate will also not change. Follow what I'm saying? When you translate all the values by 20 to the right, so the spread will always be the same. Alright? So the Sx squared, which is the unbiased estimate of what? The variance of x, will just be the same as the unbiased estimate for the variance of y. Stay the same, you get the same value. Sorry, I rushed a little bit. I will go recap on next week a little bit. Okay? And now you can do tutorial. Thanks.